Greetings, future scientists and future mathematicians, and welcome back at Say Mike Math Science Club. In this video, we'll be looking at a question which was written in November 2020. It's a question on sequence. So in this case, for 2.1, so we have 7x, y, negative 11, and etc. They say that this is actually an arithmetic sequence. Determine the values of x and y. So what you need to notice that we know that of course this is a linear sequence, right? So in this case we know that of course in a linear sequence we have a common difference. So in this case, if I were to rewrite, let me just rewrite that sequence that we have there. So we have 7 x y, and we have negative 11 there. So in this case we know that of course if I were to take this value, t2 minus t1, which is x minus 7, I must actually get the same value if I take of course t3 minus t2. So this will be y minus x, right? Because we know that of course the difference is the same in this case, and of course I would need to get the same value again if I were to take t3 minus t4 minus t3. So this would be negative 11 minus y. So what I'm going to argue is that of course all of these are actually equal to one another. So what I'm going to do, I'm going to say, right, so in this case I know that of course d is equals to d. So in this case what I'm going to do, I'm going to say that x minus 7 must actually equals to y minus x. All right, so in this case I'm just going to leave that as my equation 1. All right, and I also know that of course negative 11 minus y is also the same as y minus x, because those are the difference. We know that of course all of those things are equal. So what I'm gonna do in this case, I'm just gonna isolate x, of course y to be alone in that equation. So in this case now there are actually two ways I can three ways I can actually do this question, but I'm just gonna do it in two ways in this case, so that we don't spend a lot of time in this doing this question, making this the longest video alive. So in this case what we're gonna have would be of course 2x, all right, minus 7 being equals to y. So what I'm gonna do, I'm just gonna substitute what I have this into that equation. So in this case where there is y, I'm gonna substitute 2x minus 7. So in that second equation there that we have happening here, so what I'm gonna do, I'm just gonna rewrite that. So I have negative 11 minus y, so this actually equals to y minus x, right? So where there's x in that equation, I'm going to substitute that 2x minus 7. Where there's y, rather. So in this case, I would have negative 11 minus 2x minus 7, right? So this actually equals to 2x minus 7 minus x. So in this case, what I would have in this case, let me just scroll down so that I have somewhere to write. So in this case, of course, I'm just gonna distribute that negative there. So in this case, what I would have would be negative 11 minus 2x minus plus 7. So this actually equals to 2x minus 7 minus x. So if focus that. So of course what I'm gonna do now would be to collect like terms. So in this case I would have negative 2 x, all right, minus 2x plus x. So this actually equals to negative 7 plus 11 minus 7. So in this case what I would get in this case would be negative 3x, right, being equals to negative 3. So of course in this case I know that of course negative 7 minus negative 7, that gives us a 14, and of course that gives us negative 14, and negative 14 plus 11, that's equals to negative 3. So in this case of course on the right hand side, that's negative 2 minus 2. So in this case that gives us negative 4 plus x, that gives us negative 3. So in this case we would get x as being 1. Right, so we would know that of course x is 1. Of course, to find y in this case, what I'm gonna do, I'm just gonna take this value, I'm gonna substitute it in that equation there. So in this case what I would have in this case would be, I know that of course now y we say that's equals to 2x minus 7. Right, so in this is where there's x, I'm gonna substitute by that 1. So in this case this would be 2 multiplied by 1 minus 7, and of course we know that this would actually give us negative 5. So in this case y would be negative 5 and x would be 1. Now the second way you would have done this in this case would have been to in this case, let me just erase what I have happening here, so that of course I can show you the other way that you could have done this. So in this case was to know, and so the other way we could have done this was to find the difference first. So in this case we know that of course what we're gonna do in this case so from one term to the other we would of course always be adding a d, right? So in this case from t1 to t2 I would add a d. Then of course from T2 to T3, so I would add another D and I would add another D there. So in this case, what I'm going to argue is that 7 plus 3 differences, right, that must actually give me a negative 11. Then because now how many differences did I add from that first term to get to a negative 11? So I must have added 3 differences. So in this case, I would find D being, of course, so this would be 3D being equals to 7 and negative 11 minus 7. All right, so in this case you would actually get let's see what we're gonna get there. So in this case we have negative 11 minus 7, negative 18 divided by 3, so that would actually give us a negative 6. So we actually get D being equals to negative 6 rather. So in this case that would be 6. Just so this would actually be 6, negative 6. So again, of course, from this point I'm sure you can already see of course how we're gonna get that that x. So in this case we would know that of course 7, so in this case the first term plus a d, that must give us t2, which is x. So in this case I will know that 7 plus a d, that must give me of course that x, right? So in this case I know that that would be 7 minus 6, so that would actually give us x. So in this case x would actually be equals to 1. And of course for y, again I know that of course from the first term to that y, or you could actually take the second term, it doesn't matter, and then you add a d. So in this case from x to y, so in this case I added a d. So in this case x negative 1 minus 5, that would actually, so let's see, so we actually have of course now we know that of course d would be negative 5, right? So in this case we know that of course x plus a d, that must actually give us y. Now we know x to be 1, we know that difference to be of course 5, right? So that was 6 rather, not 5. So this would be 6, so you actually get y being negative 5. So that would be of course your y. Now of course the other way you could have done this, again there were many ways again, ladies and gentlemen. So I'm just gonna show you this formula that I told you about, that of course that I kind of came up with when I was actually bored. So in this case that formula would be to calculate that difference. So in this case we would know that of course d would actually be equals to tn minus 1. In this case that would actually be equals to the corresponding, as in this case this would be all divided by n minus of course n minus 1. All right, so this would be the positions of the terms, so this would be the values of the terms. So these are any two terms in your sequence, and then this would actually be their positions. So in this case, if you note in that so this would be of course the corresponding positions. So if you note in that so this would be of course, so if you note in that sequence that we have there, we know that of course we have T4, and of course, so you would take of course, yeah, you can take any. So in this case we know that of course we have negative 11. All right, we have of course a term which is a term for this, so this would be the values, this would be of course the positions. So in this case we have negative 11. All right, we'll subtract that negative. So what was the first term again? Let's see, so that was 67, so this would be minus 7. All right, so and then we'll divide that by the corresponding positions of those terms that you took of course on that numerator. So in this case negative 11 goes along with 4. All right, and then we subtract that, we subtract 1. All right, so in this case what we would get as d would be of course that negative 6 again, right? So that would be that, and then of course you would follow the same sequence. So this would of course would be, so you take any two terms, right? Any two terms that you know their values and of course positions. You of course just you take the other, you subtract from the other, and then of course you would do the same thing with of course the denominator in of course with the for the position, but you must just make sure that they correspond, right? Uh, so that's the important thing that you would need to note. And of course, we know that, of course, this is not given in the formula sheet. So in this case, for 2.2.1, they say for 2.2, they say that given the quadratic number pattern negative 3, 6, 27, 60, and etc., they said that determine the general term of the pattern in the form Tn is equals to an squared plus bn plus c. So in this case, let me just rewrite that. I'm just going to erase what we have happening here again. So in this case, we know that of course we have that equation, that sequence being a negative 3, we have 6, we have 27, 60, and etc. So in this case, we know that of course the first difference in this case gives us an arithmetic sequence, right? So in this case, negative 6 minus 3, that gives us a 9, right? And that 27 minus a 6, that actually gives us, so then we have 27 minus 6, so that gives us 21, and then 60 minus 27, that gives us 33. So this actually gives us 33. So we know that of course this would actually be a constant difference, right? So in this case, this would be 33 minus 21 give us a 12, and I can assure you that of course if it were that, it would actually give us it would actually get 12. So in this case, in answering that 2.2.1, this is the general term. So what we're going to argue is that that 12 there must actually equals to 2a, and then of course that 9 must actually equals to 3a plus b. Then of course this negative 3 there must actually be equals to a plus b plus c. So that's the formula that we use to determine the general term of a quadratic number pattern. So in this case, of course, we'll start by 2a, by a. So in this case, we know that of course 2a. Let me just scroll that down. So we would know that. Let me just erase that. So of course we know that of course 2a must equals to 12, and then of course a would actually be 6, right? So in this case, we of course would have of course for b, so we know that of course 3a plus b must equals to a 9, right? Then of course we know this will be 6 plus b equals to a 9, and then of course b would actually be equals to, so in this case we have 9, so it would be 9 minus 3 multiplied by 6, so this would be 9 minus 3 multiplied by 6, so this would be negative 9. So b would actually be equals to negative 9. Of course, to get c, we take a plus b plus c, give us actually 0, actually not a 0, that would actually give us that negative 3. So in this case, a, that was 6, b was negative 9, right, plus c, so that would actually give us negative 3, and then of course negative 9 plus 6, that gives us negative 3. That negative 3 would actually cancel with that negative 3 on the other side, so we'd actually get c to being 0. So in this case, we would get Tn being equals to 6n squared minus 9n plus 0. So that would be, of course, that general term for that sequence there. So in this case, they say that calculate the value of the fifth term in the number pattern. So in this case, we would know that of course what we're gonna do, we're just gonna use that general term that we got there to find the value in the fifth position of this pattern. So we know that of course for 2.2.2, in this case I'm gonna say of course t of 50, that would actually be equals to 650 squared minus 9 multiplied by 50. So if we put that into the calculator, let's see, so we have 6 multiplied by 50, we square that, minus 9 50, So it actually get to 14,550. So this would be 14,550. So this would be for 2.2.2. So for 2.2.3, they said that show that the sum of the first n first differences of this pattern can be given by Sn is equals to 6n squared plus 3n. So they actually want us to give an expression for the n, if we're of course calculating the sum of the n terms in that arithmetic sequence, sequence of course that we have there. Now remember that of course of the first difference of that number pattern, so we know that of course that would actually be an arithmetic sequence. So in this case, what we do to calculate the sum of an arithmetic sequence, let me just erase what we have happening there. So what we would have in this case, now remember to calculate the sum of n terms, of course, in an arithmetic sequence would be Sn would be equals to n divided by 2. All right. So this actually equals to 2a plus n minus 1 multiplied by d. All right. So in this case, we got, so we have n divided by 2. So this would be 2a would be 9 plus n minus 1 multiplied by d, which was given as 12, which is found as 12. So in this case, this would be equals to n divided by 2. Now I'm just going to simplify what's inside the squared bracket first so that I don't make a mess. So in this case, this would be 18. So this would be 18 plus, right, I'm just going to, of course, distribute what I have there happening there. In this case, I would have 12n, right, minus 12. So in this case, what I would have in this case would be, let me just remove, so this would be 12. All right, so in this case, what I have in this case would be n divided by 2. I'm just gonna simplify what's inside this. In this case, I would have 12n. Of course, 18 minus 12, this would actually be equals to 6. This would be plus 6, if I'm not mistaken. Let's see. So this will actually be equals to a 6. All right. So it would be a 6. So again, I'm just gonna multiply that out. So I'm just gonna multiply that out. So in this case, what I would have eventually would be n 12 n squared divided by 2, right? Minus, it's actually plus 6n divided by 2. So in this case, I would actually have 12. No, this actually be a 6. So this would be 6n squared plus 3n. So that would actually be the solution for that question there. So in this case, let me just scroll up again. So yeah, that's actually what they wanted us to show. So for 2.2.4, they said that how many consecutive first difference were added to the first term of the quadratic number pattern to obtain a term in the quadratic number pattern that is a value of 21,060. So what I'm going to do again, let me just erase what I have here, ladies and gentlemen, so that I have somewhere to write. So in this case, let me just erase that. So of course, we now have the expression for the n, for the first n first difference of this number pattern. So in this case, I know that of course the first term t1 of that quadratic number pattern plus the sum of the first n difference, this must actually give me 21 and 60, right? So in this case, I know that of course t1 I was actually given as -3, so this will be a -3 plus Sn. All right, so this is what I want to do. They say that how many consecutive first differences were added to the first term of the quadratic number pattern, right? So in this case, I want to know that how many first terms of the first difference were actually added to this to give me that value there. So I'm actually just gonna calculate the sum of all of those n first differences, right, that of course we added. So in this case, what I'm gonna do would be to say, right, so this would actually be equals to 21 and 60, right? So in this case, of course, what I'm gonna do, so in this case, Sn would actually be equals to, so let me just put that in our calculator. So we have 21, that would actually be equals to 21,063. I apologize, ladies and gentlemen, if of course I haven't mentioned it, that of course there is music actually playing in the background, of course, next door. So I just hope that the frequency of that music is not too high. Of course, if we are using the language of physics, when we are going to Doppler effect. So in this case, yeah, of course, continuing with that question. So in this case, of course, Sn would actually be equals to 21,063. So what I'm gonna do, I'm just gonna find out the number of terms the number of terms that actually give me that sum there. All right, so I'm gonna find for n. So now remember that of course we have an expression for Sn being that. So what I'm gonna do, I'm just gonna equate that Sn. Now remember that Sn is actually equals to 6n squared plus 3n, right? So in this case, what I'm gonna do, I'm actually just gonna equate that Sn there to that value there, right? So what I'm gonna do in this case, I know that of course 6n squared plus 3n, this must actually give me 21 and 21 and of course 63, right? If I'm not mistaken. I just hope I'm right at some extent. So in this case, what I'm gonna do, I'm gonna say right. So in this case, I'm just gonna transpose that value that I have there. So in this case, this will be 6n squared plus 3n minus 21,063. So this will actually be equals to 0. So in this case, what I would have, let me just erase what I have happening there. So in this case, I'm not gonna try and attempt to to factorize this. I'm not gonna do that. So I'm just gonna use that quadratic formula that we normally use. So in this case, I would know that of course n would actually equals to minus b plus or minus under the square root of b squared minus 4ac. All of that is divided by 2a. All right, so in this case I would know that of course my b would be that 3, right? So in this would be minus 3 plus or minus under the square root. So I would have b, which is 3 squared plus 4a that was given as 6, and c would be that negative 21,063. All right, so in this case, let me just expand that. So we divide all of that by 2 multiplied by 6. So I'm just gonna put that into the calculator. So in this case, we have minus 3 plus, in this case I'm just gonna start with the plus solution. So in this case I have of course a negative 3. Actually that's actually just a 3, so that's a 3 squared plus 4 multiplied by 6, right? In this case would be negative 200, and that's actually minus 4ac, not a plus, say Mike. So in this case, what we're gonna do, let me just erase that. So in this case, what we have, that's actually not a plus. That's not a plus, actually that's a minus. I apologize for that, ladies and gentlemen. And of course, what I would have in this case would be minus, right? Minus. So in this case, this would be 21,063. So in this case, we divide by 2 multiplied by 6. So what you would have in this case would be n being equals to 59. So in this case, let's see the other solution. Maybe it might be a good one again. We don't know which one is which one here. So in this case, this will be minus. So in this case, I have actually, so another n would actually be equals to 59, negative 59.5. Now this can be possible, ladies and gentlemen. We know that of course positions can be negative. Yeah, it can be negative, and also it can be a fraction at the same time. Yeah, we can't have someone who is at position 2.5. No, that can be, it can't be. We don't do that. So in this case, we would know that of course n would be 59. So in answering that question, They said how many consecutive first differences were added to the first term of the quadratic number pattern to obtain a term in the quadratic number pattern that has a value of 21,060. So in this case, how many consecutive first differences? So this case, that would be 59 consecutive first differences in this case. So that would be it for today's lesson. I hope this video helped at some extent. And of course, if it helped, be sure to like the video. And of course, if you've got any question, you're more than welcome, ladies and gentlemen, to that throw that in the comment section. And of course, if you have any question paper that you would love me to do, you are more than welcome to recommend that in the section. I'll definitely do it. So, but of course, if you haven't subscribed, please consider being the part of this growing community. But otherwise, and also share to your friends, say that of course there is a growing community there. It's a Mike Meza Science Club. But again, ladies and gentlemen, as the story always ends, this is Sir Mike signing out. Sharp, sharp.